All right, hello, welcome back to Algebraic Fractions 2. Since we're talking about fractions, quick history question: who invented fractions? We'll talk about who invented fractions when we're done with this. All right, so let's get back to adding and subtracting algebraic fractions. We talked last time we need a common denominator. In this example, the denominator is not the same, so we need to make it the same. And what is that? What we look for a common denominator, we're looking for the LCM, the lowest common multiple. So I have 4x over 7 plus 5x over 8. What do I want to be for my common multiple? The lowest common multiple is what? 56. So I need to multiply this fraction by 8 over 8, and I need to multiply this fraction by 7 over 7, and that will make the denominator 56. So I'm going to have 32x over 56 plus 35x over 56. Now my denominator is the same. I can simply add the numerators. 35 plus 32 is 67x over 56. Again, we need to check if we can simplify. It's an improper fraction, which is fine, but we need to check, can we simplify this? Do they have any common factors? And the answer is no, so that's it for our answer. Okay, go ahead, pause the video, and you try this one. Okay, so on this one, again, the denominators are not the same. We're subtracting fractions. We need, now the lowest common multiple, again, don't just automatically multiply them together. We could do 4 times 8, which is 32, but we're going to have to do lots of simplifying when we're done. The lowest common multiple of 4 and 8 is 8. So that means we only need to change one fraction. Multiply this fraction by 2 over 2. So now I have 6y over 8 minus y over 8, which is simply 5y over 8. Again, if we change the bottom to 32, it'll still work, but after we subtract, we would have to do some simplifying. Okay, what at the bottom is not numbers. What at the bottom is our variables. The same thing, the variable needs to be the same. What's the LCM of x and y? Well, in this case, we just multiply them together. So my common denominator is going to be x times y. So I need to multiply this fraction by y over y. I need to multiply this fraction by x over x. So what do I get? I get 3y over xy minus 5x over xy. My denominator is the same, so my answer, 3y minus 5x, is simply 3y. Can I simplify this? No, there's no common factors. I can't factor anything out of the numerator, so that's it. Okay, go ahead, pause the video, and you try this one. Okay, what's our lowest common multiple? The lowest common multiple is going to be 10. So that's what I need to make my denominator. Multiply this by 2 over 2, and multiply this by 5 over 5. So I'm going to get 2y over 10 plus 5 over 10. I just add the numerators. 2y plus 5 is my numerator, and my denominator is 10, nothing to simplify. Okay, pause the video and try these in your book. Okay, the first one, our common denominator is going to be 35, so I'm going to have 7 times 3 is 21 plus 10. I'm going to get 31x over 35, and that can't be simplified. The next one, my lowest common multiple, my denominator is going to be 12. So I'm going to end up with 4y plus 3y, which is 7y over 12. The next one, 6 and 5, my lowest common multiple is going to be 30. So I'm going to have 6x plus 5y over 30. The next one, 9 and 12, again, my lowest common multiple is going to be 36. Don't multiply them together to get 108. 9 goes into 36, 12 goes into 36, so I'm going to need to multiply this one by 4 over 4. I'm going to need to multiply this one by 3 over 3. So I'm going to have 16t minus 15t, which is going to be t over 36. Okay. The next one, 8 and 2, my lowest common multiple is going to be 4. So let's just multiply this by, I'm sorry, not going to be 4, it's going to be 8. So I need to multiply by 4. So 7a plus 4a, I'm going to end up with 11a, and my common denominator was 8. And the last one, my lowest common multiple of 3 and 4 is 12, so that'll be my denominator. So I'm going to have 9x minus 8x, I'm going to end up with x over 12 will be my answer. Okay, on to multiplying fractions. As is the case with numeric fractions, multiplying fractions is actually easier than adding and subtracting fractions. Why? We don't need a common denominator. Remember, we just multiply the numerators, we multiply the denominators. 2 times 7 is 14. X times y is xy. That's it, we're done. Of course, sometimes we might need to do some simplifying. In this case, there's nothing to simplify. Okay, you pause the video and multiply out these fractions. Again, very straightforward. A times b is ab in my numerator. 5 times 7 is 35 in my denominator. Nothing to simplify. Okay, next example. Again, same thing. It doesn't matter where my variables are. I multiply the numerators, multiply the denominators. I don't care if they're the same or different. X times x is x squared in my numerator. And 3 times y is 3y in the denominator. That's it. You pause the video and try this one. Okay, a times c is ac in the numerator. And b times d is bd in the denominator. And nothing to simplify. All right, what if I have a whole number times a fraction? Well, remember, whole numbers are fractions. 8 is the same thing as 8 over 1. Write it that way. Make it look like a fraction. Now, multiply out the numerators. 8 times x is 8x, and the denominators is 1 times 9, which is 9. That's it. Remember, whole numbers are fractions. Okay, you pause the video and try this one. Okay, remember, n is a fraction. Doesn't look like it, but n is n over 1. So the numerator is 2 times n. And the denominators, m times 1 is m. Okay, pause the video and do these in your book. Okay, a times b is ab over 20. X times y is xy over 21. 1 times x is x over 2y. A squared over 15. 1 over xy, and 4 is 4 over 1, gives me 4x over 3. Really straightforward to multiply fractions. Okay, again, I said sometimes we can simplify. So again, our rule here is we multiply the numerators, so we can do it this way, and this is not the preferred way, but this is the way. Multiply the numerators. 4x times 3x is 12x. Multiply the denominators. 5 times 8 is 40, and say, can we simplify this? Well, yes, we can. We can divide both of these by 4, can't we? So I can divide the numerator, and 12 divided by 4 is 3. 40 divided by 4 is 10. So this would give me an answer of 3x over 10. That's one way to do it. That's the long way, not the preferred way. Better to get into some good habits now. Look at the original problem. Can I cancel anything before I start multiplying? Well, notice I have a 4 in the numerator and an 8 in the denominator. I can divide both of them by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. Nothing left. So now if I multiply my numerator, 1x times 3 is 3x. And on my denominator, 5 times 2 is 10. Okay, it's going to be much easier to cancel first. Cancel first. Cancel first. Okay, pause the video and you try this one. Okay, before we start blindly multiplying, can we cancel? Well, look. I have a 2 on the top and a 10 on the bottom. I can divide both of those by 2, and that's going to be a 1, and that's going to be 5. 2 divided by 2 is 1. 5 divided by 5 is, or 10 divided by 2 is 5. Now I can also divide the top and bottom by 3. 3 divided by 3 is 1, and 9 divided by 3 is 3. So what do I have now? I have 3x times 1x, which is 3x squared. I know it looks like it, but I haven't actually canceled those variables. There's nothing to cancel. And on the bottom, I have 5 times 1, which is 5. Again, this is much easier than just multiplying the numerators, which would give me 18x squared, and multiplying the denominators, and then I would need to cancel that. But if I did do that, I would still end up there. It's going to be easier to cancel first. Okay, next example. Again, is there anything we can cancel? Well, look, I have a y in the numerator and a y in the denominator, because y divided by y is 1. I have an x in the numerator and an x in the denominator. X divided by x is 1. So what am I left with? I'm just left with 2/5. Okay. Now again, how is this canceling working? Well, remember, if I multiply the top, I get 2 times x times y. If I multiply the bottom, I get 5 times x times y. Remember, the order we multiply doesn't matter. And usually we write our letters in alphabetical order. So if I did it this way, it's easy to see the y's cancel and the x's cancel. That's really what I'm doing without going through all those steps. Pause the video and go ahead and simplify this multiplication. Okay, 4 and 2 can both be divided by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. X squared, I can divide top and bottom by x squared. That becomes 1. And x cubed divided by x squared becomes x. So top is 1 times 1, which is 1. And bottom is 2 times x, which is 2x. Again, what have I really done? I multiplied the top. 2 times x squared would be 2 over x squared. Multiply the bottom. 4 times x cubed would be 4x cubed. The 2 quarters is the same as a half, and the x squared cancels, leaving me with x. Okay, go ahead, pause the video, and do these in your book, and we'll see how you did. Okay, here we go. The key is, can I cancel anything? The 2 and the 4 gives me 1 and 2. So this is b over 2a. Cancel first. 6 and 9, I can divide both of them by 3. That's 3, that's 2. So I get 3x over 2y. Again, if you don't simplify, you will lose marks. You will not get full credit. 3 and 9 can both be divided by 3. And 2 and 10 can both be divided by 2. Leaving me with what? xy in the numerator and 15 in the denominator. Again, be careful when you cancel. Don't cross off those letters, those variables. Unless they're actually canceling. Okay, 3 divided by 3 is 1. A divided by a is 1. 4 divided by a is 1/2. That tidies up quite nicely. X divided by x is 1. Divide top and bottom by 2 gives me 1 and 4. So what am I left with? 1/4. Okay, the x's cancel. X divided by x is 1. I can divide top and bottom by 3. That will be 1, that will be 2. So what am I left with? 2 times 1 is 2. 7 times 1 is, and that's it. Okay, so the question was, we've done a lot of fractions. Who invented fractions? Well, it was that great Englishman, Henry VIII.